Welcome back to the 1971 Datsun 240Z build, where we're swapping in an aluminum 5.7 liter LS1 V8. We have a lot to get done before we can start this thing up for the first time. We've got a new clutch system, a power steering delete kit, a low profile oil pan, a brand new Tremec T56 Magnum gearbox, and much more to finish in order to get this thing ready for its first start. Okay, so here we have the LS1 that came out of a Holden Commodore all the way from Australia. We just need to do a few things to get this thing ready before we can put it into the 240. First off, I'm going to remove the power steering pump since I've already done a electric power steering conversion with a steering rack that came out of an Opel Corsa or Vauxhall Corsa. And we're going to replace the pulley with a ICT billet pulley, idler pulley that just basically turns and doesn't do anything. And we've got a shorter belt to put on to compensate for that removal. I'm going to remove the AC compressor. Now I'm going to keep that around just in case one day I get the rest of the components to actually put AC in the car. But for now, we don't need it and we don't want the dead weight. So I'm going to remove that. Then once we do that, I'm going to do a bit of work for the steam vent line. If you look closely, you can see that the original steam vent is, the vent port is totally rusted out. There's some holes in it. You can see where it's been leaking. So I'm going to do a conversion and make this an AN line fitting. I might pipe in the rears, but as you can see, in this particular engine, the rears came blocked off stock. So I might just leave them blocked off. I mean, hey, that's what they did at the factory. But yeah, I'm definitely going to replace the front ones because, yeah, you can see it's just totally trashed. So yeah, steam vent, AC compressor, power steering pump. Then we need to replace this flex plate on the rear with a flywheel, which I got a flywheel kit. It's an LS7 flywheel kit. So you guys can see I 3D printed. Somebody was kind enough to put a file online for a flywheel holding bracket that I 3D printed. It seems really sturdy, and I already tested it against the flywheel. It fits perfectly. So we're going to bolt that up, remove the flex plate, put on the new flywheel, get the clutch on, and then try and mate up the transmission. At which point, we'll be ready to start bolting things together. Start off by removing the reservoir. Yeah. It's easy enough. Yeah, seems to work just fine. All right. Belt is off. Ooh, maybe I should have taken note of the orientation there. Wait. It's up. Over, down, under. Over, down, under. It's the old over, down, under. Now let's just get this AC compressor removed. Ooh, those are some long ones. Okay. AC compressor off. And now we're going to remove the power steering pump, which is bolted onto the front of the right cylinder head. In order to do this, I'm just going to use a ratcheting closed end wrench slipped in between the pulley and the cylinder head itself to gain access to that front bolt. And the next bolt I was able to access through one of the openings on the power steering pulley with a ratchet and an extension. Okay, so according to the instructions from ICT Billet, it says that you bolt it straight onto the head, looking at the diagram here. So we will remove this intermediate bracket and then we'll just bolt straight onto the head. I must say, these ICT billet parts are very nice looking. Just quality made. Over-torqued it for sure. Not by much though. I was pretty much spot on. Use the old brain torque wrench. I think that one felt like it was spot on too. Yeah, not too bad. You just kind of know after a while working on these things, you know, well, it feels like it's tight enough to hold, and it feels like it's not too tight to where it's gonna strip out the aluminum. So according to the website, I had to look at a few different websites to figure out, depending on which crankshaft pulley you have on here, you select a different size belt. I went with this one. I don't even remember the dimensions of it. You would think they would be written somewhere on this package, but they are not. I believe that's what we need. It's six rib, 1,930 millimeters, I guess. Either way, if you're looking for the right one, that's it for the Holden Commodore variation of this engine. But yeah, again, if you need to check that, if you look at the center of this pulley, of this crankshaft pulley, depending on how these spokes kind of come out the center, that will kind of indicate to you which one you have, and then that will tell you which belt you need to run with this delete kit. So yeah, with any luck, this should fit. I might need to look at a picture to understand how they expect this to run, but I think it's something like that. It must be. There we go. Wow, yeah, that is a good fit. Okay, so time to remove this oil pan. Looks like a genuine GM oil pan. Nothing looks seriously damaged, which is good. At least we know the guy wasn't off-roading it. Be sure to label all your bolts too. I don't know how many times I told myself, oh, I'll never forget what this bolt did, and then I immediately forgot. So this is Okay, so oil pan is off. Now it's just time to remove the windage tray, the pickup tube, reinstall, put a bit of RTV. Apparently here at the four corners, you're supposed to put some RTV to prevent any kind of leaking. Funny to think that the oil pickup tube is literally just held on with one 10mm bolt, and if this thing becomes disconnected, the whole engine is kaput. So make sure you install that bolt. Okay, there's the old windage tray. Ooh, yeah, she's a bit sludgy. Definitely seen some RPMs in its day, but you know what? It's not too bad. It's not too bad. The next step to installing the Holley oil pan, or in my case, the clone of the Holley oil pan, is to trim your windage tray. The OEM windage tray will not clear the low-profile design of this oil pan, so you must follow the instructions to use measurements and cut off enough material for the two to clear each other. Once you've trimmed that material off, you're ready to assemble. And as you can see, we have cut the exact notches outlined in the Holley PDF document, and these notches will allow for our new pickup tube and our oil pan to not interfere with one another. So the next step will be to take a new O-ring and tighten down our pickup tube into the oil pump. And now that our windage tray and our oil pickup tube have been installed, it is time to move on to torquing down the oil pan. And following the Holley PDF document, we are required to put a dab of RTV silicone on the four corners where the block meets the front timing cover and rear cover. It is also important to torque down the bolts evenly, starting with the inside ones moving to the outside ones. Okay, 18 foot-pounds is what the doctor ordered. Who is this doctor, and why is he ordering things? That's what I want to know. The manual actually also says work your way from the center outwards. So yeah, I just snug them all up and then go for the final torque at the end. Which is pretty much what you should do with most car things. Just make sure you have even pressure. Ooh, that one feels weird. Ooh. Yeah, it's not looking very good for that one. Great. We stripped that one out. Okay, so there are two ways we can try and fix this. We can try and put a bit of weld in there and tap it out again. Or we can put one of those inserts, which might be the easier option, but not the better fix. Okay, how bad is the damage? So after discovering our stripped out oil pan bolt, I decided that the best solution would be to install a helicoil. To install a helicoil, you usually buy an entire kit which will come with the drill bit, the tap, and the helicoil themselves. I will start off by using some of this pre-taped plastic covering to mask off the area where we're going to drill into the engine block, as we don't want any small aluminum shards to fall into the engine itself. Okay, so another obvious thing, make sure that you're using some lubrication when you're drilling this out and tapping this out, and that will ensure that you have the best chance at a straight, perfectly cut thread. So you just want to use a light lubricant. I mean, you could use pretty much anything, like as long as it's not water. So I'm going to use 3-in-1, which is a pretty good light lubricant. It's like a bit thicker than WD-40, essentially. I use it on door hinges and stuff around the house. You can pretty much use it on anything you want. But yeah, it says that it cleans, prevents rust, and lubricates, so sounds good to me. Sometimes I used to have some sewing machine oil I used to use, which again, it's just a light lubricant. So, you know, not wheel bearing grease, but also not your typical motor oil. To be honest, the chuck in this drill is not very straight, so I can feel it wobbling around. I'm going to back this off and switch over to my plug-in drill. I can feel it wobbling around. I want to get as straight of a hole as possible. Now, that's probably not a huge big deal. Probably not a huge difference, but I can feel it wobbling around. I'm going to go grab my other drill. Okay, we are back with the old Black & Decker. I don't know what happened to that Bosch drill. I think I dropped it. I must have dropped it or tried to use it to break into a bank safe or something. I'm not sure, but it got hit hard. And yeah, the chuck is bent. This one is true. Also, the fact that it's a bigger drill means that you can kind of drive it straighter. You can kind of have a better grip. Yeah, I feel this one a bit warbly as well. There we go. Yeah, looks good. Yeah, I could feel that one wobbling around too, oddly enough. I mean, it looked straight, but... So before I tap it, I'm actually gonna try and get as much of that, those chips out of there. I've got some trusty Q-tips. So yeah, I'll just kind of spin them around in there. Just try and pull out all that aluminum. That aluminium, as they say over here. I feel like people get really touchy over that word. Don't know how many times I've had people complain that I'm calling it the wrong thing. Alright, so. Yeah, that feels really straight and smooth in there. And we've got, I can see down in there, it's really clean. So now we're going to go for the tap. So I believe that the threads on this tap, on these helicoil taps, are actually specific to the helicoil. So they're not like your typical, this says HSS. So, I mean, ST8 by 1.25 mil. So M8 by 1.25 mil thread pitch, HSS. So I'm assuming that that's some sort of special helicoil offset, or maybe because it's like a plug tap, which has got like a flatter tip, less of a taper. But yeah, use the tap that's included with the kit. So yeah, same process. Just gonna put a bit of 3-in-1 in there, just to get it all lubricated. And then we're gonna use an actual tap handle to drive this in, so we can make sure that we're driving it in perfectly straight. Don't stick it on the end of your drill. That will inevitably lead to some future pain. Okay, yeah. And we're going to thread this in as straight as possible. It's feeling pretty good. Now I've heard, various techniques, but most people say that you want to kind of wiggle the tap back and forth. This one doesn't feel like it's creating as much resistance, probably because we're doing it on aluminum. And, yeah, I wouldn't really go for the back and forth wiggle maneuver here. I'm just going to drive it straight in. That's usually like when you've got a lot of blockage. So as you're driving it in, you've got like the chips accumulating and stopping your tap from moving forward. But let me tell you guys and girls, this block is soft. These LS blocks, I mean, I was not torquing that bolt down super hard, but it stripped out. So here we are. Now, one thing you don't want to do is keep tapping once you get to the bottom, because that's just gonna strip it out further. So you want to make sure and turn it just till you reach the end and then stop. I can feel it. No. Still got a little bit more to go. Now, I really don't want to mess this up, because this is kind of the last chance at saving the M8 threads. I don't really feel like drilling it further to, M10. I would prefer to have all my oil pan bolts the same. Plus, I believe this might be an M10. No, the size of the helicoil tap. So if we tried to go M10, I don't know if that's even larger than this one. Yeah. I'm gonna actually back this out carefully and check to see how deep I've gone. Now, I do hate threading a tap into an existing threads. That is dangerous territory, but you know what? I want to be safe, make sure that we are not continuing into the bore. Yet we have quite a bit more to go. I'm glad I checked, peace of mind. I'm just going to clean off some of these chips on my tap. A little bit more lubricant there. And if you're threading a tap into some existing threads, you have to be careful that you don't cross thread it, because taps are really sharp. The edges on them are extremely sharp, so you want to use the lightest touch as you're twisting it in if you want to continue tapping. So yeah, and keep going with this. I know I'm probably looking like I'm being super cautious. Well, that's because I am. I really don't want to continue wasting time on this oil pan. It's a minor part of the build, and getting hung up on something because of one bolt feels like an absolute waste of time. So yeah, might as well be safe. it definitely feels like it's getting tighter. Ooh, okay, hang on, calm down. It's binding on something. I mean, I guess that's the back and forth right there. You do kind of want to turn a tap back and forth to cut those new threads. I'm going to back this out and check it again, because it's definitely getting stiffer to turn. That's looking pretty good. Let's go ahead and remove the debris here. Uh-oh. I don't know if I've tapped it far enough. Okay, that's a problem. I should have tapped it further. It's not wanting to go in, and we still got a bit of that helicoil sticking over the top. These things are extremely difficult to remove. Uh-oh, that's the tang broken. Great. So when driving our tap into the engine block, I was a bit too conservative with how deep I went with the tap, as I did not want to hit the bottom of the hole and start stripping out the new threads that we've created. And as a result, when driving in the helicoil, once I hit the part of the hole that didn't have any threads, I could feel that the helicoil would not move any further. So my natural reaction was to rotate the helicoil counterclockwise to remove it and use our tap to add some more thread, but due to the spring-like design of the helicoil, when turned counterclockwise, it will just bite into the material surrounding it and break off the tang. Now, if you ever do get yourself in a situation where you want to remove a helicoil, there are specialty tools to do so, but in this case, I actually have enough depth to provide sufficient grip for that oil pan bolt. So what we'll do is we'll come back and we'll trim off the excess to make sure that it's flush with the block. And after we trimmed off the excess part of the helicoil sticking out of the block, we now have a flush surface to make sure that our oil pan will tighten down. Okay, so after successfully installing the helicoil and getting our oil pan torqued down, I was looking for the dipstick hole on the side of the oil pan the way that the OEM dipstick went into the OEM oil pan, and I realized that it was not there. And after looking at the Holley manual, I realized that there is a plug which allows you to put a dipstick through the side of the block. Unfortunately, that plug needs to be driven out from the inside, so I will need to remove this oil pan once again to try and drive that plug out first. Okay, so we have the oil pan back off, and if you look under cylinder 6, you can indeed see the plug that you need to drive out. So I'm going to go grab a punch, and we're going to knock that thing out. Hey, live and you learn, guys and gals. Read the manual. There she blows. Try not to drop anything in the engine. That is the plug. Oh, don't drop it. Okay, so now that we've removed that plug and we have a place to put our dipstick, we're going to move on to preparing the mating surface for our long tube headers. I've already removed the stock manifolds, so now I'm just going over the entire surface with a sharp razor blade to remove any debris, and then I'm just going to clean everything up with some brake clean. Okay, so this engine is testing my patience. When I was pulling out spark plug number 8, I noticed that there was some resistance the entire way through of pulling it out, which was a red flag. And then when I started, I hand tightened all of the new plugs in and started tightening them down like normal, like I've done 100,000 times, and number 8 just felt wrong. So I pulled it out, I had a look in there, and the threads were in fact damaged. I believe that maybe the previous owner, when they went to go put a plug into number 8, they started cross-threading it and they just jammed it in there and tightened it down. Now I could have tried to jam one in there as well and tighten it down, but I came through and I basically took one of the old plugs and I cut some grooves into it. Get that to focus. And I essentially turned it into a chase. So I came through here and ran the chase through, and I made sure that it was at the correct angle. It definitely had to kind of cut some new threads a bit, which is, it's not ideal that you're cross-threading then recutting in the other direction, but I definitely didn't want to jam it in crooked. So I came through, chased it out, and then put the new plugs in, and sure enough, it's, super strong. It's holding, torqued it down just fine. So that was a narrowly avoided disaster. And yeah, I mean, it doesn't make me happy that now that the threads are kind of repaired, but still, not as strong as the rest of the threads. But to be honest, I could really feel the thread engagement when putting that plug back in, and it felt just as solid as the other ones. So even though the threads are not as healthy, quote unquote, it works. Oh my God. And there's a good example of why you always need to check your equipment even when it's brand new out of the box. There's a nut on the end of the center shaft of this engine leveler that stripped off, and luckily the engine did not come crashing down. So I went and grabbed my MIG welder and just welded that nut back on, and now I don't think it's going anywhere. Oof. Okay. And you can see here that I made good use of this 3D printed LS flywheel holding bracket. I believe I just Googled LS flywheel tool and it came right up. I printed this out of PLA, and that was plenty strong enough to hold the flywheel in place, and I'm going to probably use this a lot more in the future. Go ahead and put something down in the comments if you guys want me to make a video dedicated to 3D printing and show you the start to finish process of creating some useful tools and components. It's time to put on the flywheel. And like most things that need to be tightened down to a perfectly flush surface, it's a good idea to slowly, little by little, tighten each bolt in a crisscross pattern to ensure that your flywheel does not bind on the way down. Now that the flywheel bolts have been lightly snugged down, we can use a torque wrench to follow the factory service manual torquing procedure. For this, we will be using different torque settings, going through and torquing everything down to a lower torque setting, and then slowly, in stages, raising up to the final torque specification. Okay, so next step is going to be installing the pilot bearing. This is the needle bearing type, so it actually has real roller bearings on the inside. And some people say that these things fail and they'll destroy your input shaft on your transmission. I really don't want that to happen, but I also don't want to wait to order another solid bushing. And I've also read some people saying that the solid bushings fail even quicker. So we're just going to go ahead and use this because I've already got it on hand. And when you install it, you want to make sure that the chamfered edge part, so the sort of caved in section, is facing outward. That's going to help you align your input shaft whenever you're mating up the transmission, and the flat side goes towards the crank. So yeah, some people freeze these things so it shrinks and it's a bit easier to put in, but I did not think that far ahead. And yeah, we're just going to go in raw here and I'm going to use a 20 millimeter socket to tap that in. You're going to come in here with your socket and just give it a nice tap. You want to make sure to hit right in the center of your socket. Perfect. Okay, so we're going to go ahead and install the clutch disc. This is pretty straightforward. Essentially just the flush side of the clutch disc needs to go towards the flywheel, and the protruding side needs to go towards the gearbox. And you just place your alignment tool through the clutch disc, and then the tip of that is going to go into your pilot bearing. So when installing your pressure plate, you want to make sure that the dowel pins align, and then that will make sure that you're in the right orientation. So it's probably best to get a visual on where your dowel pins are first. And then the pressure plate will line up. Can already feel it biting on the clutch disc. That's a good thing. So I'm going to put just a dab of Loctite on the pressure plate bolts, just in case. I'm not going to go too crazy. Just a little smear. Now there's a kind of an interesting document that I was reading about how they explain. They say, oh, finger tighten these ones, then put these ones in and turn them 360 degrees, and then turn those ones 360 degrees. I mean, I've installed quite a lot of pressure plates in my day, and you just sort of torque them down in a star pattern. Well, I mean, you know, how many bolts? 6 bolts. If you don't get a star pattern, you're just basically trying to go straight across. So you do one across, you do one across, and this just ensures that you're evenly tightening it down, which is the method I'm going to go for. Okay, that's it. She's installed. And then you just remove the alignment tool. And now you're ready to bolt up your transmission. Okay, so hopefully this information helps one of you out there. I got these hydraulic lines from Hell Performance, but you could technically make your own. I really like the quality of their lines, and you can just go on their website and place an order using their configuration wizard, and they'll just send you the thing next day if you select that shipping option. And they're super quick, really helpful if you call them up and have any questions about a specific connection, or you're unsure about something. They have like a ton of knowledgeable people working there. I'm not sponsored by them. They're just been really great for some of the brake lines I've used. And essentially, if you don't want to buy a T56 external bleeder and clutch line, you can just use the configurator and make your own. You just have to ensure that your bleed line goes to a M10 by 1.5 thread. This is a fixed male, so with a crush washer, a copper crush washer, and then the actual hydraulic line is a M10 by 1, so the 1.5 on the top, and then M10 by 1 for the actual feed line.
and that one's a swivel male, so you can actually swivel it on. And then yeah, I've got that one going to a bulkhead connector, so that one will basically go through a tab mounted on my chassis. And then of course the bleed line is going to another bulkhead, so I can attach that to the same tab, and then it's got the bleed nipple on the end. So yeah, if you want to make those lines up yourself, you can. You don't have to go buy one of those expensive kits. And then yeah, so that's on there. I'm just going to mount these 2 bolts. Apparently this calls for 71 inch-pounds, which is around 5.9 something ish, which is not very much. So I'm going to put some thread locker on that. We're going to tighten that down, and then we're going to get this installed there. Just a little bit. So this is what we're working with here. Basically just that last tiny bit, which is going to be the tip of your input shaft going into the release, or the pilot bearing. Bushing bearing. Potato. You can do it. Okay. I'm about a millimeter away, although I don't know if that matters. And it's on the top, so yeah, go in. When I say I don't know if it matters, I'm saying I don't know what I'm saying.
Now that we have the LS1 on the engine hoist, it's just a matter of slowly lowering it into the engine bay and using the engine leveler to guide the tail housing of the transmission into the transmission tunnel. Okay, so the LS is mostly installed. We did run into a few small issues, one of which was that the motor mount here was interfering with the alternator bracket. Now this may not happen to you if you have an LS that's out of a different vehicle, because they had different configurations with the accessory drive belt. But yeah, with the motor mounted all the way back, the mount was running into the bracket, so I just had to basically cut off some and clearance it out. Otherwise, we also ran into a small issue with the starter. So this is the stock starter, and this was originally an automatic car, so I don't know if it's to do with that, but it couldn't push all the way into the T56 without, it was just bumping by just a few millimeters. I had to clearance it a tiny bit with a file, and then it went in. But you can still see that there's a little bit of a gap there, and I can't get rid of that gap. I bet if I bought an actual aftermarket starter, it would probably be fine. But yeah, with it mounted up, you know, that bell housing is right up against the back of the block, so I'm not really sure why there's a teeny gap there. But yeah. So what's left to do, tighten down the motor mounts, mount them to the cross member, get our headers back on, and then install the T56 mount. So the T56 is just hanging out right here, looking good. We just need to get the bracket in there and mount that up. And it's already looking pretty good on the inside of the car too. Yeah, I mean, you know, we still got a little bit of ways to go. So, you know, once that engine comes forward a little bit, you know, we're gonna be right in line with a good spot to mount up our shifter. It's not gonna be sticking up this high, I don't think. It'll go down a bit, but I'm going to adapt the shifter from the original transmission, the 4-speed, and I'm gonna weld something onto it. You'll see that later. But yeah, time to get moving. Okay, ladies and gentlemen, it is important to admit when you've made mistakes, and in this case, I made an expensive one. So essentially, if you go to all the suppliers for LS swap kits for your Z, then you'll notice that if they supply a T56 transmission mount, they don't say which T56 to buy. In fact, if you go to the forums and other places where they talk about LS swap Zs, no one really talks about which T56 to buy. So I just assumed that it would be the T56 Magnum, the standard T56 that you would get. They sell two other versions, the T56 Magnum XL and the T56 Magnum F. XL stands for extra long, which would put your shifter in way far back in this location, or the Magnum F, which stands for F body, and it would put it pretty much exactly where you would want it for the Z. Well, I got the Magnum Standard, which basically has now put my shifter super far forward, and thus I will need to fabricate some sort of dogleg offset shifter that comes out this direction and then goes up to put it in a natural position. Now, you know, it's not the end of the world, but it would have been nice if you're spending all that money on the gearbox to get the one that just works. So another thing to note is that there is a slight tilt in the transmission. So if you look at the transmission here, it looks like it's tilting to the left. So there's not only a tilt, but you can see it's actually touching the metal here. Now it's touching because the shifter hole is actually to the right. If you look at the amount of metal here on the right and the amount of metal here on the left, you'll notice that the shifter hole is offset. And that's because I think that this car was designed for the Japanese market, where the driver would be on the right-hand side, and it would just put the gear stick closer to the driver, making it easier to grab gears. In this case, we're gonna have to just chop out a little moon shape here just to make room, so that way this boot doesn't chafe itself apart.
So that's going to do it for part 2 of the 1971 Datsun 240Z LS swap build. We've gotten so much done already. We've gotten the engine prepped and installed, brake lines refreshed, engine and gearbox mounted, a custom fuel system installed, and much more. Stay tuned for part 3, where we'll be installing a Haltech ECU, finishing up the fueling system, and seeing if this thing fires off the first try. And hey, while you're still here, go ahead and like and subscribe, so that way I can continue making more build videos just like this one. Thanks again for watching, and see you next time.